Hello, my dear students. My name is Subhash Chandra, and I teach the chemistry ITJ subject. So, we'll here discuss the importance reactions of chemistry. Importance reactions of chemistry in the organic chemistry. Organic chemistry. So, one shot for the ITJ NEET exam. One shot for the ITJ NEET exams. So, in the first slide, here now represent introductions overview of the carbon carbon bond, and formation and transformation. Formation and transformation. Carbon 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 bonds. Generally, in the carbon carbon bonds, carbon carbon single bond in the saturated hydrocarbon and carbon carbon double bond and carbon carbon triple bond in the unsaturated hydrocarbon. So carbon carbon single bonds, these are sigma bond, and in the carbon carbon double bonds, one single bond and second is a pi bonds. Any we represent the first pi bonds and second represent the sigma bonds or any more. First bond also we represent the sigma bond and second bond also we represent the pi bonds. Anyway, same as in the carbon carbon triple bond, one bond. In the three bonds, one bond is sigma bond and the another two bonds are pi bonds. In the chemical reaction, sigma bonds are more stronger than the pi bonds. Okay, sigma bonds are more stronger than the pi bonds. Means that in the chemical reactions, when between the carbon carbon, first pi bonds are dissociate. First pi bonds are dissociate. Here now, first pi bonds are dissociate. As example here now, carbon carbon double bonds, that's are pi bonds and that's are sigma bonds. So first dissociations of the bond is pi bonds and dissociate one carbons containing negative charge, second carbons containing positive charge. Similar as in the carbon-carbon triple bond. And when containing the sigma bond, this dissociation is same. Bond sigma bond dissociate then form the one carbocations and second is a carboanions. Carboanions. Same as these are dissociation because most important sigma bonds and pi bonds dissociate in a generally organic chemistry or generally organic reactions. So I will move to the second slides. First chemical reaction, acetylation. 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 First chemical reaction, benzoyl chloride. Benzoyl chloride and ethyl alcohol then form the ethyl benzoate. Benzoyl chloride, benzoyl chloride, COCl plus ethyl alcohol C2H5OH. Then in the acidic medium or acidic medium then form ethyl benzoate. Then for ethyl benzoate. Ethyl benzoate. Here, discuss the process of the formation of ethyl benzoate. In the benzoyl chloride Cl and alcohol OH. So H and Cl then form the HCl minus HCl then form ethyl benzoate. Here, in the presence of acid, H plus ions, protonation of the chlorine, then HCl remove and CH3, C2H5O and benzoate C6H5CO then combined from the ethyl benzoate. Okay, so next slides we discuss the Woods fitting reaction. Woods fitting reaction. According to the Woods fitting reactions, here two words belonging Woods and fitting reaction. Woods and fitting reactions. Woods fitting reactions. One aryl halides and second is alkyl halide in the presence of sodium. In the presence of sodium, then form the aryl alkyl compounds. Aryl alkyl compounds. Woods, when in the chemical reaction, say that Woods makes that aryl group. Aryl halide, suppose that X, any halogens, plus fitting. Fitting represent the alkyl halides. X. In the presence of sodium metal, react the sodium metal in the presence of ether, dry ether or ether. Anyway, so here the X, NaX. Then for AR, aryl alkyl group formed. And here remove the 2NaX. 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 So here represent the example as C6H5Cl plus 2Na plus alkyl halide. Alkyl halide C2H5Cl. C2H5Cl in the presence of dry ether. Dry ether. Then for Cl, Na and Cl removed. Then form C6H5 C2H5 plus 2NaCl. 2NaCl. These compounds name is a benzene alkane. Benzene alkanes means that these are alkane group. Alkanes name is ethane, benzene, ethane are aryl ethane groups, and NaCl is a salt form. I hope you understand. Then form the second reaction. Next is a Woods reaction. Woods reactions here only represent the woods. Here only represent the woods. Alkane synthesis. Ethyl bromide to ethane. Methyl bromide to ethane. Woods means that here represent the only alkyl group. Suppose that methyl chloride CH3Cl plus in the presence of metal as a Na, only take the Na plus methyl chloride ClCH3. Here same as a CH3Cl. Here the NaCl in the presence of dry ether. In the presence of dry ether. Then for CH3 means that methane, one carbon methane and second carbon methane. Methane or ethane. That's a ethane form. And another product is a NaCl4. NaCl4. Okay. Woods fitting reaction and second is a Woods reaction. So next slide in the slide, next chemical reaction is a Wolff-Kishner reaction. Wolff-Kishner reaction, part 1, mechanism aldehyde ketone to heterozones means that any aldehyde or ketones in the presence of hydrogen then form hydrazone compounds. Hydrazine means that NH2, NH2, that's a hydrazine. Then at last form hydrazone compounds. Here the aldehyde, any first example is an aldehyde C double bond O H. That is aldehyde group. That is a aldehyde group and react with the hydrazine. Hydrazine NH2 NH2 hydrazine. Then form the hydrazine. And here they remove hydrazine H2 and here the O means that H2O. H2 means water molecules remove. Then for C N H NH2. That's are hydrazone compounds. CnNH2, that's are hydrazone compounds. Here the second group is a 1, 2, 3 alkyl groups. H2O water molecules removed, then hydrazone form. Hydrazone form. That's the compound name is hydrazone. Here the right now, if the here represent the R alkyl group. So example, I give you the example. If aldehyde the CHO R CHO and if present the ketone then R and CO. So here right now ketones example is a R C double bond O R dash same are different and react with the hydrogen NH2 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 and NH2. Here the R dash C carbon molecules carbon to nitrogen carbon nitrogen and H2O water molecules remove H2O remove. Here the H2 and O oxygen H2 water molecules remove and next NH2 combined then the form hydrazone means that any aldehyde or any ketones when react with the hydrogen then form remove the water molecules and then form the hydrazone compound. Okay, so you are I hope you understand. Then the second reaction second chemical equation is a Wolff-Kishner reaction part 2. Wolff-Kishner reactions part 2 same as hydrazone in the chemical reactions also be formed. Hydrazone in the chemical reactions be formed. Part 2, then the means advanced type component compounds also be product to be formed. Then any aldehyde or ketone when react with the hydrogen NH2 NH2. Any aldehyde or ketone react with the hydrogen, then form the hydrazone. So, one steps again. Here the R, here the R, C, N, NH2. That's That's compound name is a hydrazone. That's compound name is a hydrazone. And these hydrogens react with the in the presence of base. In the presence of base, in the presence of base, normal alkane compounds form. Here they remove N2. Remove the N2, then form C H H2. That's here it depends upon the R alkyl groups or lower members or higher members. Here they define the, for the example, if we take the ketone R C double bond O R R dash plus NH2 NH2. Then for hydrogen, then for hydrogen R C R dash and N dot NH2. Here the remove water molecules H2O. H and oxygen. Here the oxygen H2O minus H2O. Then in the presence of base, in the presence of base, N2 molecules removed. Here the N2 molecules removed. Then for R C R dash and two molecules removed to remaining H2. Remaining the H2. That's our alkane 4. That's our alkane 4. Means that Wolff-Kissner reactions. Wolff-Kissner reaction, two types of Meili product form. First is hydrazone. Second is a alkane. Higher members of alkane 4. Okay, so here the discuss about the which process then form the lower members to higher members alkane form, means that ketones are aldehyde to formation of the alkane. First, again revise, ketone react with the hydrazine, that's name is a hydrazine. Then react to remove the H2 water molecules. Then for hydrazone and react with the base in the presence of base and to remove then the form alkane groups. So I hope you learned that or define the next chemical reactions. Williamson synthesis. Williamson synthesis. The Williamson synthesis use of the symmetrical and unsymmetrical formation of the ether. Symmetrical and unsymmetrical formation of the ether. What use of the chemical reactions? Formation of ether. Symmetrical and unsymmetrical. The process formation of the ether process is very simple. We take the sodium ethoxide, any sodium ethoxides, any alkane groups. Suppose that C2H5ONA. And second is if we form the same types of alkane in the ether, then similar take the halides. Similar alkane take the halides C2H5Cl. Okay. Then in the presence of base, here they remove Na and Cl, then the remaining C2H5O, C2H5. Here both are alkanes are similar, means that symmetrical ether. And if we form the unsymmetrical, then we take the different types alkane group C2H5O, Na plus. Any lower members or higher members we take. We take the lower members. CH3Cl in the presence of base. Okay. So Na and Cl remove. Then from the C2H5O CH3 plus NaCl4. That's our unsymmetrical ether, and that's our symmetrical ether. Both are defined the equation, symmetrical and unsymmetrical. So I hope you consider the chemical reactions, and I discuss the next chemical reactions, Ullmann reactions. Ullmann reactions. Biphenyl ether, the biphenyl synthesis using the copper powder. Using the copper powder in the Ullmann reactions. So these reactions name is metallic reactions because the copper use. Biphenyl, two phenyl groups. Phenyl groups generally take the iodide, phenyl iodide plus Cu plus phenyl iodide. Phenyl iodide. Phenyl iodide. Cu copper plus phenyl iodide. Here the Cui removed from the ether. Biphenyl compounds for biphenyl compound for biphenyl compounds for so this होगा इसको इरेज करके फिर न्यू प्रोडक्ट्स फॉर्मेशन करते हैं रीराइट बाइफेनिल कंपाउंड फॉर biphenyl compounds form and CuI copper second oxidation state Cui2. That's our Ullmann reactions. Very simple reactions. Aryl halide in the presence of copper and at the using the ether, then copper iodide separate and biphenyl compounds form. That's the name is a biphenyl compounds form. So I move to the next chemical reactions, that is a Stephan reactions. That is a Stephan reactions. Alkyl nitrile compounds nitrile reduced to the aldehyde in the presence of tin chloride and HCl. Tin chloride and HCl. Here the nitrile. What is nitrile first? Nitrile is a cyanide group. Nitrile is a cyanide group. We write now. Okay. That's our name is a cyanide and also name as a nitrile. So I'm going to the move to the equation, chemical equation, nitrile RCN in the presence of SnCl2 HCl means that acidic medium, means that acidic medium. Then for R, after the hydrolysis, after the hydrolysis, RCHO, aldehyde 4. After the hydrolysis, aldehyde is a 4. RCH, RCHO, aldehyde 4. Okay. So next chemical reaction is a Stephen reactions. Next chemical reaction is a Schouten-Baumann reactions. Schouten-Baumann reactions. Reactions number is 8. Schouten-Baumann reactions. In the reactions, aryl amide react with the acetyl chloride. Acetyl chloride. Aryl amide C6H5NH2. Aryl amide react with the acetyl chloride. Acetyl chloride means that C6H5COCl. Then, in the presence of basic medium, here the HCl and here the H removed, means that minus HCl removed. Then form C6H5, here the remaining NH. The remaining NH, and here the found C6H5COCl. We get now COC6H5. That's name is a phenyl aryl amide. That's name is a phenyl aryl amides. The simple reactions, Schouten-Baumann reaction, alkylations of phenol, amines. We take the here amines. Also, we take the phenol in the presence of basic medium. Here, we take the amines, then amines NH2 groups, HCl and H minus HCl in the presence of basic medium, then form the amide. NHCO, that's our amide group, phenyl aryl amides. Second, next equation is a Sandmeyer reaction. Sandmeyer reactions. Diazonium salt to the chlorobromobenzene. Chlorobenzenes are bromobenzenes formed by the diazonium salt. So first we will discuss the which process the formation of diazonium salt. So we take the here the diazonium salt. We take the first aniline C6H5NH2 and sodium nitrite NaNO2 plus HCl in the presence of HCl. Then for diazo salt and triple bond and triple bond and triple bond and Cl. That's compound name is a diazo salt. Diazo salt or diazonium chloride. With the help of diazonium chloride or diazo salts, formation of the chlorobenzene, bromobenzenes or alcohols, many different types of phenolic products form. Here the formation of the chlorobenzene. So in the Sandmeyer reaction, according to the Sandmeyer reactions, react with the copper chloride, then form the C6H5, that means that phenol, and Cl, chlorobenzene 4. That's our Sandmeyer reactions. Sandmeyer reactions. Highlights: copper is the first oxidation state. Cu, first oxidation state. Means that CuCl, we take the Cl, X means Cl, then form chloro, X means Br, then form the bromo. Chlorobenzenes form. Here the production is a chlorobenzene form. Same as a bromobenzene. So here the CuBr, then form bromobenzene form, bromobenzene form. Simple reactions. Okay. I hope you understand. Then we discuss the next Rosen-Mond reactions. Rosen-Mond reactions. Rosen-Mond reactions. Acid chloride. Acid chloride. Acid chloride to aldehyde. Acid chloride to aldehyde in the presence of lead or barium sulfate. So let's discuss the acid chloride C6H5COCl in the presence of lead, barium sulfate plus newborn hydrogen. Then form the aldehyde, is that benzaldehyde C6H5CH4. Benzaldehyde or alkyl aldehyde we also form CH3COCl plus H. Newborn hydrogen then form in the presence of Pb, BaSO4, then form the H removed, then form CH3CHO, acetaldehyde. Compounds are formed. And here 1 HCl, then minus HCl, 1 HCl, then minus 1 HCl. Means that Rosen-Mond reactions only formation of the any acid chloride, the acetyl chloride, then form the benzylides. Only use this. So total is a 10 chemical reactions. Total is 10 chemical reactions, 1 to 10. So, and next chemical reaction discuss the next day. Thank you.